Hello, today I am going to explain you what is a single phase induction motor is, its basic construction and working. My name is Archana and I am working as an assistant professor in the electrical department of Bar Basilis College of Engineering and Technology. So let's go on to the topic that is single phase induction motor, its working and construction. So to start with, let me explain you what is the construction of a single phase induction motor is. The single phase induction motor construction is very much similar to that of a three phase induction motor. So in a three phase induction motor, we know that we have a stationary part called a stator and also a rotating part called a rotor. So this also consists of a stationary part called a stator and a rotating part called a rotor. But in case of a three-phase induction machine, since it's a three-phase, we have three windings in the stator, whereas for a single-phase induction machine, what will be the differences? It will be having a single-phase winding in the stator. Now let's go into detail what is a stator is. A stator consists of a steel frame and it encloses the hollow cylindrical core which is made up of thin laminations of silicon steel in order to reduce the losses which are present, which can be the eddy current and the hysteresis loss. A number of evenly spaced slots are provided on the inner periphery of the lamination and the stator windings will contain the single phase winding. The stator will have a stator frame, it will have a stator pole as well as a stator field winding, but the stator field winding will be made up of single phase winding. Now next is the rotor. As we have discussed in case of a three-phase induction machine, the rotor can be classified into two types based upon the construction. One is squirrel cage rotor and other is slip ring rotor. So what is the difference between the squirrel cage and the slip ring rotor is, in the squirrel cage rotor, the bars are actually shorted by means of the end rings, whereas in case of the slip ring rotor, we have the rotor which is connected in the star connection and that is connected by means of a slip ring brush via an external resistance. So when the motor is picking up the required speed, this external resistance will be cut down. Now what is the purpose of connecting the slip rings and the brushes is nothing but, in case of a squirrel cage rotor, the starting torque is very less, whereas for a slip ring rotor, the starting torque is high. So in order to achieve that, we are mainly connecting or we are using the slip ring construction. But still, the slip ring construction, the maintenance, etc., is very much costly compared to that of squirrel cage. So the most commonly used kind of the rotor connection is squirrel cage rotor. So in this case also the rotor is a squirrel cage rotor and it will consist of laminated cylindrical core having parallel slots in its outer periphery. One copper or aluminium bar is placed in each slot and all the bars are joined by means of end metal rings which are called as end rings, which I discussed before, and these rotor conductors are permanently short circuited. The entire construction resembles to the squirrel cage and hence the name squirrel cage rotor. So this is the basic figure in case of a single phase induction motor. There you have the rotor and as well as the stator. The stator is having only a single winding or a single phase winding, whereas the rotor constructional base, it is a squirrel cage rotor where the bars are shorted by means of the end rings. Now next is to understand what is the principle of operation in case of a single phase induction machine. As discussed earlier, for a three-phase induction machine, the principle of operation was rotating magnetic field. So let's see whether the same principle of operation is applied for the single phase as well. Here, in case of a single phase induction motor, the principle of operation is once again electromagnetic induction, and when the single phase is supplied to the stator winding, it will produce a magnetic field. The flux is stationary in space and it will pulsate in the magnitude, that is, the flux varies sinusoidally with respect to time. And this no rotating magnetic field is created in the stator. So what does this mean? Since we have only a single phase winding, this single phase winding will naturally produce one flux. This alternating flux will be constant magnitude and it will be varying, but since only one single flux is produced, that single flux we can consider to be a vector sum of two vectors which is equal in magnitude and opposite in direction. So this is what is explained by the double field revolving theory, where suppose I am having a single flux that I can consider as two vectors which are equal in magnitude and they are opposite in direction. So these two vectors will produce equal paths in the opposite direction, which will make the rotor unable to rotate, that it is simply will vibrate. So what does this mean is, since this is equal and opposite in magnitude, what will happen is the net flux will be zero. So the resultant flux, whatever it is zero, that will mainly result the rotor not to rotate but to simply vibrate. That is why we generally say that a single phase induction motor is not self-starting, and we need to think of some starting method to make it self-starting. However, if the rotor is rotated in one direction by some external means, it will continue to rotate in the same direction. So we should think of some strategy by which I should make the single phase induction motor as a self-starting. So if it is started to rotate, means it will continue to rotate in the same direction. So that is being governed by creating one more alternating flux. So what we are doing is, I have a main winding in my single phase induction motor. I have incorporated an additional winding, and this additional winding will mainly result in two separate fluxes. So when two separate fluxes are being produced, what will happen is that will cause the resultant flux, and that resultant flux will have a magnitude as well as it will vary with respect to position. So what will happen in net effect is the rotating magnetic field will be produced. So when the rotating magnetic field is produced, rest of the principle of operation is similar to that of a three-phase induction motor. So what is here discussed is the same. To make the single-phase induction motor self-starting, the rotating stator magnetic field is required. Two alternating flux with a phase angle in between should be developed, so that the interaction of these two fluxes gives the resultant flux which is rotating in nature. And this is achieved by converting a single phase supply into a two-phase supply by making use of an additional winding. When the motor attains this significant speed, the additional winding may be removed depending upon the type of motor we are using. For removing this additional winding, what we have an additional construction part is, we have a centrifugal switch. The centrifugal switch behaves as similar to that of an ordinary switch. So when the motor is attaining the required speed, the machine will have both the main winding as well as the additional winding. So when it has achieved that particular speed, this additional winding is cut down by making or by opening the switch. So when the switch is in the open position, what happens is this additional winding will be removed. So this is the pictorial representation in case of a winding in the stator. That is, we have a start winding. This start winding is nothing but our auxiliary winding, and the run winding is nothing but our main winding. So in our system we have this main winding. In addition to that, we have an extra or an auxiliary winding, the start winding. So this winding will help, or it will produce an alternating flux. Thereby this system is made a two-phase system in order to make the single-phase induction motor rotate. So thereby we can start the single-phase induction motor, and when these two windings are being used, what will happen is a rotating magnetic field will be produced. When the rotating magnetic field is produced, naturally the rotor conductors will have a current. So whenever the current carrying conductor is placed in a magnetic field, it will induce an EMF, and this EMF will produce a torque, thereby the rotor will start rotating. So this is the basic principle of operation in case of a single phase induction motor. So we have two separate windings to create necessary rotating magnetic field, and these two windings are named as the run winding or the main winding, the start winding or the auxiliary winding. The principle of operation of a single phase induction motor is not similar to that of a three-phase induction motor. Only difference is that we need to create a rotating magnetic field. For that, we are making this single phase system